their cars on charge and lights and Devonport. A great lunch. Well done with the menu. That was good. Vegetarian, vegan options. Very nice. You know, it's an ideal time now that the government's left to thank them for sponsoring the conference. I'm not sure if they'll sponsor the Queensland one. It just shows how in tune our Tasmanian politicians are, that they will come and listen and face the crowd. He didn't have too much spin and he looked like he knew what he was talking about. I was hoping he'd say, well, we're going to do it tonight. Who's got a screwdriver? Let's go. Let's roll it out. Your politicians, yes. Okay, is Darren Mooney in the room? Darren Mooney, just stand up please, ladies and gentlemen. Not only do we have a good government, but Darren Mooney's from our RACT. Thank you, Darren. Well, we did get lots of money out of them from this year. They'll certainly pay the next time we do this, won't they? RACT are really one of the leading organisations in Tasmania, along with some of the other sponsors that you see here today. It wouldn't happen without them. We'd be at McDonald's and having terrible food and in a dodgy venue. Oh, look, the tides come back in. Thank goodness for that. So, where's Michael DeMarco? Michael, can you stand up too, please? Ladies and gentlemen, this is Tesla's first mechanic in Australia. And I wanted him to come up and talk, and he said, how much are you paying me? So he's, that's it. And his dad's here. His dad's taken over Amaroo Racetrack, and he wants to create an electric vehicle test, demo, training, excellence hub. So he doesn't want applause, and there's a handwriting letter to the politicians. So hopefully someone in the New South Wales organisation will grab hold of him. D West, where's D? Just stand up for a sec, D. D's involved with women in electric vehicles. It's called STEM. Is it STEM?
No, STEM just stands for science, engineering, mathematics, and technology. But anyway, can I have all the women, when this session's done, come up front so I can have a picture of us all together? Boys not invited. I just want to represent.
I knew she'd do a better job of it than me. Okay, no, I challenged the Minister for Energy, Elisa Archer, the other day, and for Tasmania, I think she's like 4'2" and about 60 kilos wet, to a scooter race, but she hasn't turned up, so, you know, that's the way it goes. We're on time. Electric transport's a big part of what we're here for. I think it's going to be quite the invigorating session. Again, a Q&A at the end, so plenty of time for questions. Our first speaker, of course, is our good friends from ChargePoint. But you're going to do a pitch first, aren't you?
It's part of the sponsorship.
Are you going to sing and dance?
No,
I'll hand it over to you.
Thank you very much to Clyde and the AEVA, there we go, for allowing us to be a sponsor. So it's nice to see everybody having the ChargePoint lanterns on. So yeah, obviously I'm sponsoring this session. I look forward to hearing from Christian and Gelco and Tritium, and I've got one, who did I forget? AVA, Charles. What is ChargePoint? Paul. We're the world's largest network of independently owned electric vehicle charging stations. So around the world, we've got over 40,000 charging points. The majority are in the United States, and Mexico, Canada, Europe, and Australia and New Zealand. Paul. Our mission, EV charging everywhere. We've got solutions for home, at work, around town, and out of town. And all of them have different rates of charges, etc. But basically we want to ensure that there's solutions so that any EV driver never has an excuse to sit there and say, I can't plug in my car. So our job is to make things easy. We've got our demo units out there. So we are a Silicon Valley-based company, so it's all about the software and the app. And I can show anybody how we connect our driver database with our owners and what the site hosts can do with the system. And a lot of people come to me and ask, what is your business model? Explain your business model. And there's been lots of ups and downs in this industry over the last 10 years. And ultimately, the charging model of the future is going to be very different than today with petrol cars. There will be various different business models out there. And I'm not saying one business model is the right one. You've had examples such as Better Place from a few years ago that went bust. I'm sure many of you are familiar with that. Some of you probably sold Better Place cables. I actually have one in my i3 as a relic. But we are a business-to-business company, and we sell charging stations that connect to a network, and we provide a software-as-a-service plan. Any business that's connected to the ChargePoint network has to buy into the cloud. It doesn't cost you EV drivers. It's the majority of your EV drivers here attending this conference. It doesn't cost you a cent unless the site host wants to charge. So we provide all those billing systems in the background and transaction-based services. And what are we in Australia? We're currently the largest public network. We opened up the first public charging station in the country in 2010 in Sydney. So ChargePoint was here since the beginning of EVs, when Nissan and Volt and Mitsubishi brought in all those EVs 8 years ago. Here's our current map. It's a mix of AC and DC. We've got over 400 charging points, and just for the heck of it, I put up our demo unit out there. And, just for today, the Waterfront Center does have a EV charger, but at best you'll get 240 volts through the system. But if anybody wants to see a demo, I can show exactly how it works and explain it. So there we go.
Can I use that for the afternoon?
$1.45 an hour.
No, forget that.
There's someone out in front.
So thank you very much. I look forward to all the talks.
That was a good 3 minutes, wasn't it? Yeah, thank you. I don't really need the microphone in a small room. I haven't met the next man, but I've heard a lot about his company. State of battery, technology and trends. Ladies and gentlemen, you probably know him real well. He looks sharp and smart and fluid, ready to take on the world. Please welcome Phil Gell from Gelco.
Welcome to the AEVA conference down here at Devonport. Beautiful view out there, isn't it, mate? No? So, I'm here to discuss battery technology and trends, which has happened in the last couple of years of the last decade of development, sort of thing. But what might be happening in the future as well with, in particular, batteries. So that's a pretty common one, which is seen the 18650 battery, which is used in a lot of Teslas and that sort of thing, or all Teslas basically at this point, as well as a lot of other electric vehicles in the industry. Lithium-ion batteries present a landmark technology that has made the current generation of electric vehicles possible. However, the day of their demise, well, is in the future a bit, it's within view. The issue they've got really is the capacity is becoming too developed, basically. There's not much more room for development on the lithium-ion cells, and whilst they're still a very, very good technology, very reliable, very safe, there's obviously a further development required in regards to how we can extract more power out of batteries. So, as it says on the bottom one there, if drivers keep demanding longer ranges and faster charging times, then a better technology has to be found. There's a bit of a slideshow. I actually took a photo while I was up in Detroit earlier this year. It gives an indication of the battery cost per kilowatt hour over the last 8 years. You can see there at 2009, it was up around $1,200 per kilowatt hour. And now at 2017, we're sitting on around about $200 per kilowatt hour. That gives an indication of the cost of batteries over the period of the last, basically 10 years. So, and according to the fellas in Detroit, at least anyway, $700 is the cut-off point where EVs become more financially viable than a diesel or compressed natural gas, basically. So, I don't know what it is for internal combustion with petrol, but it's hard to say at this point. This gives an indication of different batteries' capacities versus weight and price. So we've got the traditional lead acid there. You're looking at basically, where was it? There was a good figure on that one. Lead acid's never that good anyway, but yeah, the energy density, that's right. Yeah, 35 watts per kilogram on lead acid. As you can see, it's slowly moving up. lithium-ion phosphate sitting at basically 100 watts per kilogram of capacity, and the best one being lithium cobalt at 167. That's in the current market, or what's been offered in the market, sort of thing. Big thing also is the charging times is quite low on both of those technologies. Whereas lead acid, to give you a reference or a 0 point, is at 8 hours. The safety rating on them, they say it's good, and it is good with the correct battery management systems in place. There's a lot of talk, and you've seen a lot of videos over time of these exploding batteries. Well, if you go driving nails through anything, usually they do tend to catch fire and fail. So that's one idea that we found. This is gives you an indication of the life cycles of lithium-ion batteries. So you're looking at a pretty high volume of life cycles before you start to get some serious degradation of the battery. So I mean, 3,500 cycles is a lot of cycles. Now, we do a lot of battery validations and that sort of thing for various companies, and we've done a fair bit with lithium-ion stuff, and I can tell you now we've put them through some pretty intensive testing at high temperatures, extremely low temperatures, and these batteries just keep on soldiering on. It's an amazing thing by comparison to some of the traditional types of battery chemistries that are out there, basically. So this is very representative of what we've actually found within our technical centre out there at Adelaide. This is a typical commercial battery pack which you would see in your vehicles. This was taken out of a mobile Citroen. Basically, it's their battery pack for one of their like a little delivery vehicle, which is just a commercially operated vehicle. So this gives you an indication of the way the cells are mounted and that sort of thing. These aren't 18650s; these are 26500s or something like that, which is a bit similar to these cell batteries. But you can see the pack configuration and how they're all managed. Now, on each cell there is a battery management system on board, which controls a lot of your charging algorithms as well as discharging units, and that will also incorporate your safety shutdowns due to over temperature or overcharge or charging runaway and that sort of thing. Always pretty critical to keep that under control, and that's what manages your safety protocols basically. Here's your pouch style lithium-ion kits or cells. We've done a fair bit of work with these ones, and they're amazing what they can get out of these batteries. Like, we're talking some which would be much bigger than this laptop here, delivering 200 amp hours consistently time after time with discharge. And it's pretty exciting to hold so much capacity in such a small amount of space, sort of thing. From a battery point of view, who likes making things go to their limits, I don't mind these sorts of things. So these are certainly in use nowadays, and you'll find in a lot of your vehicles, as well as the lithium-ion batteries which are commercially available in your case size, your den sizes and that sort of thing. Okay, so people often wonder about safety on this type of technology. Well, yeah, it is an issue. The explosions and fireballs that documentary makers revel in are not the norm. You look at your mobile phones and that sort of thing. Most of your electronics gear, like your battery on your PC, they don't catch fire under the normal conditions. They do get hot, there's no doubt about it, but what part of components don't get warm is you're running electronics through them. So if looked after in the correct environment, they're quite safe and very stable. There's enormous amounts of safety infrastructure installed in these battery packs, such as what you find in your vehicles, and you're flat out getting the real issues that you get. There has been a few fires here and there on electric vehicles, but that's usually not a result of the charging system. It's usually a failure of some sort of a debris damaging a battery pack or something like that. The systems have failed. But they don't explode like they do in the movies, so we're pretty safe in that one. Unfortunately, it's a slow death. People got plenty of time to get out of the car and walk away. And video it, mind you. They also always send a video before they do anything, they'll put the fire out. It's got me stumped, that one. But moving forward, one technology that's been getting a tremendous amount of attention from researchers is that of the solid-state battery, which uses a solid electrolyte instead of the liquid electrolyte as used in your lithium ions. Solid-state batteries could theoretically have double the density of capacity per kilogram, and they're expecting it to last at least twice as long with its duty cycles. They're saying a few more times than that, what developers are saying, but even saying that twice the expected lifespan is still a massive improvement. So it uses a non-flammable electrolyte, it's usually glass, polymer, or a combination of a silicon, and they eliminate a lot of the safety issues that plague the lithium-ion cells. So you might still get your heats and that sort of thing generated, but you won't have the fire generation out of that as a result of that heat that's being generated. Give you an indication of the physical size of it as well. So this is your basic, this is both the same capacity battery packs. So you're looking at roughly half the physical size as well as a reduction in weight, which obviously makes it a lot easier to operate, and a bigger capacity availability if you've got a similar amount of real estate within the vehicle. So that's going to make a massive difference in range that can be developed over vehicles over time, as well as charging times, because they are developed to be a much faster charging profile. Interestingly, Panasonic, Tesla's battery suppliers also taking a look at the solid state technology. Their statement is, well, I think the existing technology can still extend the high density of lithium-ion batteries by 20 to 30%, which is a possibility because they're doing it in such serious volumes. But there is a trade-off between the energy and density and the safety. And as they say, if you look at it for more density, you have to think about additional safety technology as well. And solid-state batteries are one answer. So that's what Tesla's comment on is. We sit there and refer to Tesla and that sort of thing, but they are a bit of a market leader in this sort of thing. They're pushing pretty hard with it, so it's good to see that they're pushing a lot of technology forward. And it says the next comment there, engineers have been pushing limits of lithium-ion technology for decades. They can reach an energy density of about 300 watts per kilogram, which is getting close to the theoretical maximum. Like I said, there's a little bit more to pull out of it, but not much. Keeping in mind that current lithium-ion is 100 watts per kilogram, and nickel cobalt, which is much better than that, is 160. So we're looking at 2 to 3 times the physical size smaller than what the lithium-ion battery comes in at. So that's a pretty big saving in itself. So it appears that lithium-ion will continue its reign for a few more years at least. However, the post-lithium holy grail is still out there, and as likely as not, the knights on the table which will be leading it, such as Tesla, Mitsubishi, Nissan, BMW, and whatever China and India vehicle manufacturing comes up with, will be the ones to give us the answer. If China and India go on a certain path, that could well change the way the rest of the world looks at with their battery capacities. They are such a as the young lady was saying before about the markets in China is such a big one. I was up there a few weeks ago, and it's amazing the EV as well as the e-bike scooters market is massive. So this is all driven by our own obsession with distance, because we all want to travel further, cheaper and faster. High technology and vehicles demanding power, such things as air conditioning, heating systems, all that sort of onboard computers and electronics, and our desire to charge as fast as we can to drive through the future with battery technology further. So that's just another pack of another photo of the pack there, which is used in the industry. So yes, thanks very much for that.
Batteries have never been so interesting, and my level of comprehension has gone through the roof. Thank you, Phil. We'll be dragging you back up for the quick Q&A later on. Thank you. Batteries, big part of what we're thinking about, isn't it? No? Well, I think that was a great infographic. Good chart, that one. I took a photo. Anybody else take a photo of that chart comparing batteries, life, cold weather? Yep. We'll post that one too. Ladies and gentlemen, charge your tech. How fast is fast enough? Never fast enough, eh? That'll be a big conversation.